Okay, so today we're doing section 5.4, day 1. This is still logarithms. I'm going to show you a couple of basic things that you could do to solve some log equations and to simplify some logarithms. The first thing we're going to do is simplify some logarithms, and we're going to use that around the circle method that I taught you last week. So to start off with, let's do this logarithm. So if I gave you log base 2 of 2 to the third. What I would want you to do to start with is you're going to set it equal to x. So you're going to go equals x. Once you have that, you're going to go around the circle, just like I taught you how to do last week. So it's going to be 2 to the power of x equals the middle. So 2 to the power of x equals 2 to the power of 3. This should look like a problem that you've done already. When these match each other, you get to ignore the 2's, and the answer is just x equals 3. So what you'll enter in is just the 3. You will not write x equals 3, you will just write 3. So we're going to do a couple more of these because these are really quick and pretty simple to do. So let's try log base 5 of 125. Well, if I take that equal to x, go around the circle, I'm going to have 5 to the x equals 125. Well, what power of x gives you 125? If you think about it for a minute, 5 squared is 25. But what is 5 cubed? So if you check on your calculator, 5 to the third power, 5 to the third power is 125. So this over here is really 5 cubed. So once again, the 5's would be irrelevant and x would be equal to 3. I did not make that up so that they had the same answer. They just happened to have the same answer. Okay, so what about if I gave you log base 4 of 4? If I set it equal to x, that would be 4 to the x equals 4. What's the power on 4? Well, it's 4 to the 1. So the 4's are irrelevant, and you would have x equals 1. So hopefully you can see right now that these are pretty quick and pretty easy problems to do. A couple more. These ones are special. So if you have log, let's say base 3 of 1 equals x, because you'll be given that, set it equal to x, go around your circle, you'd have 3 to the x equals 1. You might go, well, 1's not a power of 3, but that's because it's a very special problem. There's only one power in the world that gives you 1 as an answer. That is 0. Anything to the 0 power equals 1. So this x here has to be equal to 0. And that's just something you have to remember. You have to remember anything to the 0 power equals 1. 2 more. If we have log base, let's say 5 of 0, and then we set that equal to x. 5 to the x equals 0. There is no power in the world that's going to give you 0 as the answer, unless you're taking 0 to the power. But I'm taking 5 to the power. So this is the D and E, I think is the thing they put on there. It might be no solution, not for sure what it has on WebAssign, but you can't do this. This brings me to a very important rule, and you might want to write this down. You, on the inside of a log, can have no negative, and you can have no 0. So on the inside of a logarithm, you can never have a negative number, and you can never have 0, because it's impossible. Something that's impossible to do. All right, and so there's one more little rule, and it's kind of what I always saw with the silly rule for logarithms, and it's an exponential form. If you've got 2 to the log base 2 of, let's say, 3 power, as long as this matches this, your answer to this problem will always be what's ever in this position. So the answer to this problem is whatever is in this position. It will be equal to 3 in this case. So if it had been a 5, it'd be equal to 5. It was a 7, it'd be equal to 7. So as long as this matches that bottom number there, which it will, it's going to be equal to whatever number's in that position. So that's the first main topic for today. Okay, so we have basically one more little topic, and that's solving a log equation. Okay, so the first type of log equation is the one where you read around the circle. So if I gave you log base 2 of x minus 1 equals 3. Yes, this is in parentheses and has something a little different on the inside, but doesn't make a difference. So we're going to take and go around the circle. 2 to the third equals the inside. So it's 2 to the third equals x minus 1. Do you know what 2 to the third is? I bet most of you guys do. If you don't, you got your calculator, but 2 to the third equals 8. So this is 8 equals x minus 1. So easy to solve. You'd add 1 and you get x equals 9. Now, before you finish a log equation, you have to go back up to your original problem and check and make sure that in here, in this case 9 minus 1, make sure it doesn't equal 0 and it doesn't equal a negative. Well, we know 9 minus 0 or 9 minus 1 is 8. 8's not 0, 8's not a negative number. So this is perfectly acceptable. Remember that I showed you on the last page or before I erased, this number in here, whatever's in here, can't be 0, can't be negative. So let me show you an example of when it is negative or when it is 0. So if I gave you this situation, log of x minus 2 equals log of 3x. This is an easier log equation because you don't have to go around the circle with it because there's log on both sides. So in this situation, when there's log on both sides like this, you can cancel the log and just set the insides equal to each other. So to solve it, I would subtract x, get negative 2 equals 3x. No, I'm sorry, that was my fault. Equals 2x, that was a silly mistake. Divide by 2, and you're going to get x equals negative 1. So I go back up to my inside of my logs, and I see if it equals a negative. Well, if I do negative 1 minus 2, I'm pretty sure that's negative 3. And inside of a log, you can't have a negative. So this is an example of no solution. And I'm pretty sure on these ones, it's no solution and not the D and E. You'll be able to tell on WebAssign, they'll tell you. So our very last one that we're going to do, very last problem today. Hopefully you're seeing how this is a pretty simple lesson today. We're going to do log base 3 of 2x plus 3 equals log base 3 of 5 minus x. So is this a going around the circle problem, or is this where we cancel the logs? Well, there's log on both sides. So given that there's log on both sides, you cancel the logs. It is not a read around the circle. The read around the circle is when you just have a number over here and not log on both sides. So what I mean about reading around the circle is if you had log base 3 of 2x and it was equal to 1, that's read around the circle. See? Okay, so this one, we're just going to take 2x plus 3 equals 5 minus x and solve it. So we're going to add x. We'll get 3x plus 3 equals 5. Subtract 3. 3x equals 2. Divide by 3, and it is possible to get fractions. Double check and make sure it's going to give you a positive number inside. So if you do 2 times 2/3 plus 3, I don't even care if you work it out. If you think logically about that, 2 times 2/3 is definitely a positive number. And if you take a positive number plus 3, you're going to definitely get a positive number. So that side's great. Over here, same thing. 5 minus 2/3 5's much bigger than 2/3. So if you do 5 minus 2/3, pretty sure you're going to still get a positive number. So 2/3 is a terrific answer for that problem. So that's our lesson today. Hopefully these seem fairly simple for you to solve, and I will see you tomorrow for day 2.